So we're going to continue with 10.4 logic gates. So we see the video recorders, the washing machines, the fire alert, any system for alerting, any device or gadget have what switch. We'll find the logic gates in it. So what is the logic gate? So here we have an example for two switches, A and B. They are normal switches for sure, as you can see here, but they work as a normal gate. Okay. Here, the output is what it's this lamp. And here we have the battery. Now, this circuit is what is series. That means if these two switches not on, the lamp will not work. So here we have something called the truth table. Truth table. So this truth table, it gives us each case the switch in and what is the output will be. So for example here, switch A and switch B and Q is the output. So the input is what? A and B, and the output will be this lamp, the Q. So for 0, it means the logic gates have even 0 or 1. The 0, it means 0 volt, there is nothing getting out. And the 1 usually it's 5 volt. But we put 1, that means there is something there. Okay? Like the digital, remember? So in 10.1 when we talk about the digital, it's even 0 or 1. So here in this case, if 0, A is 0 and B is 0, the circuit won't work. That means the output will be what? 0. In the other case, A is 0 and B is 1. That means it's what? 1 is connected. But there's still this didn't work. That means also the output is 0. Another case, if A is 1, A is connected and B is 0. That means also it won't work. For that case, if A is 1 connected and B is 1 connected, then the lamp will work. So in this gate, the lamp will work in one case when A and B are connected. So we have many gates, and, or, and not. So also they are what? Each gate have 2 input and 1 output. So let's see the AND is like new to multiply, okay? So we'll see also the cases as we did here with the truth tables. So this truth table for AND, if A is 0 and B is 0, the output will be 0. If like you multiply 0 by 0, it's 0. You multiply 0 by 1, it's 0. Everything you multiply by 0, of course, it's 0. So 1, 0, this 1, this 0 is 0. 1 and 1, it's what? It's 1. That means the output in the AND gate, it will be 1 in one case, and the rest will be 0. Just in the case A and B are what? Are 1. Moving along to the gate OR. OR have also 2 input, of course, like we said, each one. A, if it's 0, again to the truth table. B, 0, the output is 0. Now the OR is like the sum, okay? So you calculating 1 plus 1, okay, 0 plus 1. So 0 plus 0, it will be 0. 0 plus 1, it will be 1. So the multiply and the sum or the plus is what is for just you know it easier way. So if we want do the sum for this, 0 plus 0, it will be 0. 0 plus 1, it will be 1. 1 plus 0, it will be 1. 1 plus 1, it will be 1. It won't be 2, okay? This is not normal numbers, as I said. It's just, even there is volt, most of the time it's 5 volt, or there is not. So when this have volt and this have volt, this have volt, okay? So in OR gate, it all will be on just in case A and B are zeros. So this you can connect it in your mind to the series circuit and this to parallel circuit. Here in the last gate we have what? NOT. The gate NOT, it's like you put something negative, okay? Like you multiply by minus. So if you put 0, it will be 1. And if you put 1, it will be 0. But this gate have just one input and one output. So in case 0, if you put 0 here, the output will be what? 1 to the truth table. If we put here 1, the output will be 0. So everything you put, you'll find the opposite. That's why it's not. Now, sometimes we put more than one gate together. For example, here we have A and B connected to the AND gate. The out is C, and then it's connected to NOT gate, and then to the output is Q. So A, B, C, now they are input because the last output is here. Okay, so they are together. Later we'll mix them together to see what we'll get. Let's go to the truth table again. 0, 0, and what will and 0 and 0 give us 0. 0 and 1 go to the end will give us 0. Now 1 and 0 will give us also 0. 1 and 1, the AND gate, it will give us 1. Okay? Now this C, what happened to it is going to gate NOT. So that means all the things from C will be the opposite on Q. So 0 became 1, 0 became 1, 0 became 1, and 1 became 0. Okay? Again, the 0 and the 1, they're not numbers, they just a sign. There is volt, 5 volt, or there is no volt. So let's take another example. You can see this drawing in your book, page 235. This record button connected to AND gate. To recording circuit. Okay, recording button, and here we have play button. So, okay. Now, at the end, go to the gate AND. when it will work, just in one case, when it's one, right? That means this recording with, for example, this recording camera, it will not record or give one to the recording circuit just when we push the two buttons. So the button is not pushed is what? Is 0. Then both not pushed is 0. If I push just the record one, it won't work. If I just push the play one, it won't work. I have to push both of them until it starts recording. Okay? So you can see in page 234, you find here in the picture, you see, so this is a DVD player, and they say you're using what logic gates when you press the button of the DVD player. So everything is switched, is related to gate. Here we have logic IC package, internal circuit. So 12 of the pins, so this you can see it here. This is the IC. It's electronic component. So 12 of the pins make connections of the gates on this chip. This is called also the chip. This is in the plastic thing. The other two are for the power supply. So this 2, 4, 6, 7, and the other side 7. That means this chip have 14 pins. Okay. So both of the pins, or just 2 of the pins, are what? Are for power supply. Very good. So the power supply have negative and positive, or 0 plus 5, and the others are all of them for the gate. So again, the gates is just switches, 2 input, 1 output. Just the NOT is 1 input and 1 output. That's it for this video today. Thank you for listening. Take care of yourself and wear your mask.